Hello, this is Proximity Math. Today I'm going to go over the 2005 Aime Ii number 9. Alright, so for how many positive integers n less than or equal to 1000? So for how many n such that this is true, is sine plus I cosine of t to the n equal to sine of nt plus I cosine of nt. True for all real t. So if it's true for all t, and it's for a certain n. For certain n, it's asking how many less than or equal to 1000 is it true for all t. So if it's true for all t, this just means this is an identity, which means it's always true for any n. So it's always true. It's always true for a certain n. So you can get from this to this using a certain n, and it'll be true no matter what t you plug in. So you have to find for which n these two are equivalent, regardless of t, basically. Okay, and first of all, you might know this is really familiar, since we have cis theta equals cosine theta. Sine theta. Right. And this is Euler's complex number form. But this is instead sine plus I cosine, which is different from this. Slightly different. But it definitely has something to do with this, obviously. Okay, so first of all, we can use co-angle identities. If we let A equal, you have to notice that cis of 90 minus theta, 90 degrees minus theta, equals, now we can use co-angle identities, which is just equal to sine of theta plus I cosine of theta. Alright. So then now that we found how to get to this form, we can use this and solve. Okay, so what this equation gives us, and I'm going to write it in exponential form. So e to the I 90 degrees, or sorry, I'm going to use pi over 2 now because it's the actual number, pi over 2 minus t. That gives us this expression raised to the n power, just multiply the power by n, is equal to the right hand side, which is if we plug in n for t instead. And this is, be careful, this is different because you're plugging in nt instead of t. So this just gives us the co-angle identity, except we have to substitute instead of t, we get nt. So on the left, we use Wim-Weber's formula for raising a complex number to the nth power. On the right, it's something different, right? Basically, everything's the same except what argument we get in here. So the number on the right of the I and the e to the I, these two have to be the same. Or you can just take the natural log of both sides and then divide by I. So anyway, if we distribute the n on the left side, we get pi over 2n minus nt equals pi over 2 minus nt. And then this might be a downfall for some people, but you have to notice exactly what's going on here. These two angles are the same. These two are the angles. And that means they can they give the exact same number as long as they're off by a multiple of 360 degrees. Which means they're just equivalent mod 2 pi. I know that's really weird, but that's all. Probably the best way I can put it. So as long as these are equivalent mod 2 pi, like one is 30 degrees and the other is 390 degrees, they're off by 360, they're gonna give you the same exact complex number if you put it into Euler's formula and take the cis. Okay, so now we can subtract the nt regardless, and then subtract the pi over 2, and we have 0. Okay, so n is a positive integer less or equal to 1000, which means this does not make it 0 to make it mod 2 pi. We need this to make it 0 mod 2 pi. And what I meant by this is just a multiple of 2 pi k. Just so for some k, this has to be 2 pi k, a multiple of 2 pi basically. Okay, now we get 1/2, and now we get 4k. So this would satisfy everything as long as n, I'm gonna add the 1, as long as n is 4k plus 1. So now that we have the general form of n that satisfies everything, we can put together these two restrictions, and we get it's asking how many positive integers basically satisfy these two. All right. So if it's one more than a multiple of 4, it can be 1, 5, and so on. 1, 5, 9. All right. But you have to be careful here. We can be off by 1 easily. So it can be 4 times 0 plus 1, 4 times 1 plus 1, all the way until 4 times 249, because 4 times 250 is 1000, and we're adding 1, so it has to be less or equal to 1000. All right, and it's easy to verify the first one, for example, to make sure we did everything correctly. We have, actually, that just gives us the same exact thing. Yeah, it's correct. If we plug in n equals 1, it's correct. Or you can check other ones. But anyway, we get 0 through 249 for n, which gives us 250. Thanks for watching. This was a really nice and simple problem with complex numbers, and I hope this helped you.